Hello, welcome to my channel. Thank you for being here to watch my videos. In this video, I will show you a simple technique to remember values of any trigonometric functions across the 4 quadrants. I have made a separate video on relationships of quadrants and trigonometric functions, and I highly encourage you to watch that video before this one. Let's start with discussion of some basic mathematical facts. The value of x-axis beyond this origin, which is 0, 0, to the right is always positive, and the value of x-axis to the left of origin 0, 0 is always negative. The value of y-axis above the origin, which is 0, 0, is always positive, and the value of y below the origin is negative. And the angle measurement is always made from positive x-axis in a counterclockwise direction. So that means this angle is positive, and if it's measured clockwise from positive x-axis, then it becomes negative angle. Let's use a unit circle to better understand the magnitude and signs of each of the trigonometric functions. A unit circle is actually, it's a circle with a radius of 1 unit. So the radius from origin to point A is 1 unit. And it's drawn on the Cartesian coordinate system, which is x-y axis, with origin of 0, 0 in the middle. Therefore, if we take point A, that means x is 1 and y is 0, because on x-axis the y value is always 0. So if you take point E, this is positive y-axis, and this point is 1. This point is x coordinate 0 and y coordinate is 1, because on y-axis all the value of x is 0. If we take point I, here it's a negative x-axis, and this is negative 1, and y value is 0. Similarly, if we take point M is on negative y-axis, that means x is 0 and y is negative 1. So in all 4 corners, there is the size of the radius is 1 unit. Alright, so we have established the basic mathematical facts, plus we have drawn a unit circle of radius 1. So xy coordinates is always considered as cosine of theta and sine of theta. So point B is actually, it's a value of angle theta here, cosine of theta and sine of theta. Let's say this is angle 30 degree. So sine of 30 degree is 0.5 and cosine of 30 degrees √3 divided by 2. So we can put this, the x coordinate is √3 divided by 2, and the y coordinate is sine theta, which is sine of 30 degree 1/2. Or if we consider angle 0 right on the x-axis here, that means sine of 0 is 0, sine of 0 is 0, and sine of cosine of 0 is 1, which is 1 here. So if you take another angle, which is the most common one, 45 degree, let's say this is 45 degree, That is, cosine of 45 degree is square root of 2 divided by 2, and sine of 45 is square root of 2 divided by 2. You can find these values from any trigonometric tables. And the tangent of 45 is actually sine of 45 divided by cosine of 45, which is tangent 45 is equal to sine of 45 divided by cosine 45 degree, which is root 2 divided by 2 divided by root 2 divided by 2, which is basically 1. So we have 1 here. So cosine is root 2 divided by 2, and sine is root 2 divided by 2. The next common angle is 60 degree. If you take this angle as 60 degree, that is sine of 60 degrees square root of 3 divided by 2, and cosine of 60 degrees 1 over 2. Okay, so tangent of 60 degree will be the square root of 3. So the coordinate of point D will be x 0, the square root of 3 divided by 2 divided by and sine of 60 degrees root 3 divided by 2, which is 1 over 2. Alright, so sine of 60 degrees square root of 3 divided by 2, and cosine of 60 degrees half, 1 over 2. So that's x coordinate is cosine of 60, which is half, and y coordinate is square root of 3 divided by 2. Then the next very common angle is 90 degree. So sine of 90 degree is 1, and the cosine of 90 degree is 0, and tangent of 90 degree will be 1 divided by 0, which is infinity, I would say. So that is 0 and 1. The next thing will be transferring these common trigonometric functions into the other higher angles by just using unit circle. So before that, what we have to do is actually, for each angle that we have established here, like 0 degree, 30 degree, 45 degree, and 60 degree, and also 90 degree, we draw a straight line across, for example, point B all the way to point J. That makes a straight line. So as you know, the angle of the straight line is 180 degree. So if we add up 180 degree to 30 degree, it gives us 210 degree. So I will do the same, just connecting point C and point K with a straight line, and I'll get 45 degree plus 180, that gives us 225 degree. And then the same to 60 degree. If I draw a straight line from point D all the way to L, I'll get this straight line. That means 180 degree plus 60 degree, it gives us 240 degree. And if you go to the 90 degree here and then draw a straight line all the way down, I'll find this point M. So point M is actually 180 degree plus 90, which gives us 270 degree. And I keep doing the same. This is 120 degree. So just the same. This is 135 degree, 150 degree, and 180 degree. So if we add up 180 degree to 120, it becomes 300. So we can join point F and point N with a straight line, and then it becomes 300 degree. So if we add 180 to 135 degree, it gives us 315 degree. And then the same to 180 plus 150, it gives us 330 degree, and finally 360 degree. Alright, once we establish the common angles across the unit circle, the next step will be mirroring all the values in quadrant 1, which is quadrant 1 here, to quadrant 2. This is quadrant 2. So how do we mirror these values? We mirror these values using positive y-axis. So if we mirror all the values to the respective points in quadrant 2, we will have exact same values, but some of the signs are changed. So what it basically means is, if you are mirroring the value of point B, which is √3 divided by 2 and 1 1.5, using the positive y-axis, what does it mean is the y-axis coordinates will not be changed, but the x-coordinate will be changed. That means its sign will be changed, because we are mirroring this value into the negative x-axis side. So that means the positive y-axis values, they remain the same. They remain the same both in magnitude and sign, but the x values will be changing its sign. That means what it means is, actually, if you mirror this value into h value, that means what it means is, actually, the x value will be minus √3 divided by 2. I think I have to use different pen. And what it means is, actually, minus √3 divided by 2, and the y value will not be changed. It remains the same. The same for point C. If we mirror the point C using the positive y-axis towards here, what it means is the g coordinate will be minus √2 divided by 2, but the y value will be the same, 2/2. If we mirror this value D to point F, we will find the x value change its sign, 1/2, which is negative, and the y-axis will remain the same. Okay. All right, that's pretty much what it is. So we don't need to remember the sign 120 or sign 135 or sign 150 or whatever. So we just, once we know these values, we can simply construct them on a unit circle and then mirror them to the quadrant where these angles are found. So we can do the same for quadrant 3. This is, for example, quadrant 3. So quadrant 3 is basically between minus x-axis and minus y-axis. As you may expect, all the x and y coordinates are negative. That means negative x and negative y. So if we mirror this value all the way down to here, what we found is the sign, both signs will be changed. That means this is minus x, because we are mirroring this value on negative x-axis. That means all the negative x-axis value remain negative, and the y-axis become negative. So because we are mirroring with respect to negative x-axis towards quadrant 3, where all the x and y coordinates are negative. So that means negative 1/2 and negative √3/2. If you mirror this value all the way to point K, you find minus √3/2, √2/2, sorry, and minus √2/2. And if we mirror this h coordinate to J, what we can see is actually minus √3 divided by 2 and minus 1 over 2. All right. So we can also mirror quadrant 1 value into quadrant 4. This is quadrant 4. In quadrant 4 is actually between plus x and minus y axis. That means negative y coordinates and positive x coordinates. So we can mirror everything here. For example, what it means is x remains positive, y will change its sign. Root 3 over 2 and minus 1 over 2. And if you mirror this one all the way here, you'll find root 2 divided by 2 and minus root 2 divided by 2. And the n value will be here. If you mirror this d all the way to point n using positive x-axis, that means it becomes 1 over 2 positive, and the root 3 over 2 will change its sign, minus root 3 over 2. So we found all the values for all the most common trigonometric functions. So by using this simple trick, we can find any trigonometric functions across the 4 quadrants. And any angle which is not included here can be calculated using different trigonometric formula, which are not discussed here, and they will be discussed in another video. So using these values, we can construct sine, cosine, and tangent curves, and these curves will also be discussed in another video. All right, so if you found this video helpful to you, please subscribe to my channel and hit the like button below, and your comments and feedbacks are highly appreciated. Thank you again for watching this video.